Right now, there is a jet engine sitting under the wings of every single C919 plane flying in China today, and it was not made in China. It was made by a company from America and France. That single part costs almost 1/3 of the entire plane's price. And in 2025, the United States government simply stopped shipping it. For 5 weeks, China's newest airliner program nearly stalled out completely, so China built its own engine to replace it. But here is the twist nobody expected. That new engine has flown only once, on a giant military cargo plane, never once with a regular passenger on board. And China is about to bet its entire national airliner program on it anyway. Before we go further, if you like these deep dives into aviation stories, hit that like button. It genuinely helps this channel keep making them, and subscribe so you don't miss what happens next. Because what happens later in this video might change how you think about who really controls the skies. We are going to look at the numbers behind this new engine, the secret test flight nobody talked about at first, and the real calendar that tells you exactly when this bet either pays off or falls apart. Let's get into it. The plane that needs a favor. China has a plane called the C919. Think of it as China's version of the planes you have probably flown on before, like a Boeing 737 or an Airbus A320. It is already flying today. 3 big airlines in China use it. Millions of people have already sat in its seats, flown across the country, and landed safely without a second thought. The C919 took years and years to design, test, and finally get approved for regular flights. Engineers worked on the wings, the cabin, the landing gear, and every wire running through the plane. By most measures, it is a real success story. Proof that China can design and build a full-sized passenger jet from the ground up. But there is a problem hiding in plain sight, and it is the exact problem this whole story is about. The engine, the part that actually lifts the plane into the sky, is not Chinese at all. It is called the LEAP-1C, and it is built by a partnership between an American company and a French company, 2 of the biggest names in aviation, working together to build the thing every C919 depends on. Picture the engine like a giant fan bolted to the front of the plane. It sucks in air, squeezes it tight, mixes it with fuel, and blasts it out the back to push the plane forward. Simple idea in theory, but incredibly hard to actually build well. There is a reason only a tiny handful of companies on the entire planet can do it, and most of them have been perfecting this craft for over 50 years. This one part alone makes up close to 30% of the total cost of the aircraft. Let that sink in for a second. Nearly 1/3 of the plane's entire price tag is locked inside one component, and that component comes from somewhere else. So every single C919 that rolls off the factory floor in China is flying with a foreign heart beating inside it, no matter how Chinese everything else about the plane might be. This is exactly the piece of the puzzle that explains why China has been racing so hard behind the scenes to build something new, something we are going to dig into very soon. But first, you need to understand just how badly that foreign dependency can hurt, because it already has, and it happened faster than anyone expected. When the favor got pulled, in July of 2025, something happened that changed everything. The United States Department of Commerce suspended export licenses for that LEAP engine. Just like that, on paper, in a government office, a decision was made that reached all the way into a Chinese airplane factory thousands of miles away. For 5 straight weeks, the American company was legally not allowed to ship engines to China at all. No engines meant no new planes rolling off the line. Production nearly ground to a halt. China had planned to deliver dozens of these planes that year to airlines eager to expand their fleets and add new routes. Airlines had already scheduled routes, Passengers had booked tickets on planes that had not even been finished yet. Leasing companies were waiting on aircraft that suddenly had no clear delivery date. The entire supply chain, built around one engine coming from overseas, froze in place almost overnight. Instead, by the end of 2025, only 32 C919s had actually been handed over to airlines. Far below the original target, orders were sitting there, airlines were ready. But the planes simply could not be finished without that one imported part. No matter how advanced every other part of the aircraft was. This single moment showed China something uncomfortable, something that probably kept a few engineers and officials up at night. No matter how advanced your airplane factory is, no matter how many planes you can build a year, if someone else controls the engine, they control whether your plane flies at all. All the wings, the seats, the cabin, the paint job, none of that matters if the heart of the plane cannot legally be shipped to you. That is not a small lesson to learn. Airplane wings, seats, and the body of the plane can be built almost anywhere in the world with enough time and investment. But a jet engine needs materials that can survive heat over 1,000 degrees Celsius, blades machined down to fractions of a millimeter, and decades of trial and error that most countries simply do not have lying around. Only a handful of companies on the entire planet know how to build one safely enough for a passenger plane, and none of them, until now, were Chinese. So the question became unavoidable. Could China actually build one of its own, from scratch, good enough to trust with real passengers, and good enough to remove this single point of failure forever? That question is exactly what leads us to the engine everyone is talking about now, and here is where the story gets genuinely interesting. Meet the new engine. China's answer is called the CJ1000A. It is built by a company called AXE, which stands for Aero Engine Corporation of China. And on paper, this engine looks like it means serious business, not just a backup plan thrown together in a hurry after the export ban. It is designed to produce about 28,200 pounds of thrust. To picture that, imagine 14 full-size pickup trucks, all pulling in the exact same direction at full power, all at once, all connected to a single rope. A longer-range version pushes even closer to 29,500 pounds of thrust. That is almost identical to the foreign engine it is trying to replace, pound for pound, nearly matching it in raw pulling power. And it is not just similar in power, it is nearly a physical twin too. The fan is about 1.95 meters wide, roughly as tall as a doorway in your house. The whole engine is about 3.29 meters long, close to the size of a small delivery van parked in your driveway. Nearly the exact same size as the LEAP engine sitting under C919 wings right now. That similarity is not an accident, and it matters more than it might seem at first. It means this new engine could potentially be swapped into the same engine slot without redesigning the wing or the mounting points underneath it. Engineers call this drop-in compatibility. In simple words, you do not need to rebuild the whole car. You just need to swap the engine block and keep everything else exactly the same, saving years of redesign work and billions of dollars in the process. Inside, the details get even more impressive the closer you look. There are 18 fan blades made of titanium, and they are hollow instead of solid. A hollow blade is lighter, which lets it spin faster without snapping under pressure, almost like a straw that is strong enough to survive spinning thousands of times a minute without bending or breaking. There is also a 10-stage compressor, which is basically 18 rings of blades stacked together, each one squeezing the air a little tighter before it gets burned for power. Think of it like squeezing a sponge over and over, each squeeze pushing a little more water out until almost nothing is left. That is what these compressor stages do to air, except instead of water, they are packing more and more oxygen into a smaller space so it burns more efficiently. And inside the combustion chamber, the small space where fuel actually ignites, there are 3 fuel nozzles built using 3D printing, which is honestly one of the most advanced ways to build these parts in the entire world today. Traditional manufacturing would require welding together dozens of tiny metal pieces. 3D printing lets engineers build the whole nozzle as a single piece, with fewer weak points and better performance under extreme heat. This is not old leftover technology dusted off and repackaged. This is a genuinely modern piece of engineering, built with real intention and real investment behind it. But there is still one very big question left hanging in the air, and it is the one question that decides whether any of this actually matters yet. Has it actually flown? Yes, but not where you might expect it to have flown first. This engine has already flown, just not on the C919 yet. It flew on the Y-20, a massive Chinese military cargo plane that is often used as a flying test bench for brand new engines before they are trusted anywhere near regular passengers. Here is how that works. Engineers strap a brand new engine onto one side of a proven aircraft like the Y-20, while the other side keeps its normal, trusted engine. That way, they can watch how the new engine performs in real air, at real speed, under real stress, long before anyone stakes a passenger's safety on it. If something goes wrong, the plane can still land safely on its other proven engine. This kind of testing usually takes months, sometimes years, and involves thousands of hours of data collection. Engineers watch how the engine handles temperature changes, how it responds during takeoff and landing, and how it holds up after repeated use over time. Every flight adds another piece of information to a giant puzzle that eventually decides whether the engine is ready for regular passengers. As of March 2025, top leadership at AC, including a former deputy general manager at Comac, said the engine's performance had exceeded even their most optimistic internal expectations. Read that again, because that is a strong statement coming from insiders who usually choose their words very carefully in public. They said test flights on an actual C919 were coming soon. That sounds incredible. And honestly, it is a very strong sign that things are moving in the right direction. But here is the catch that most headlines completely skip over. Soon and certified are 2 very different words in the aviation world. An engine can fly perfectly in a test, again and again, and still be years away from being allowed to carry regular passengers every single day on a commercial schedule. So how far away are we really talking about here? That question brings us to the part of this story that most people never actually see, the real calendar sitting behind all the exciting headlines and hopeful statements. The real timeline. Chinese certification for this engine is now expected somewhere around 2027 to 2028. Actual daily use on a C919, flying real passengers on a real schedule, could begin around 2028 to 2029. And full mass production, where these engines roll off the line in large numbers ready to power dozens of planes a year, is not expected until around 2030. To put that in perspective, this engine was originally supposed to enter service back around 2020 or 2021. So this is not a small delay tucked into a footnote somewhere. It is a delay measured in years. And in an industry where safety comes before speed, that gap is completely understandable, even if it is frustrating for anyone hoping for a quick replacement to the current foreign engine. Certification itself is a long and careful process. Regulators do not just check if the engine works, they check how it performs in freezing cold, in extreme heat, during sudden bird strikes, and even during rare emergency situations most passengers never think about. Every single test has to be documented, repeated, and verified before regulators sign off on it, which is exactly why even successful test flights do not guarantee a fast certification timeline. There is also a technology gap worth being honest about, because pretending it does not exist would not be fair to you. Compared to the LEAP engine it is replacing, most engineering experts say the CJ1000A is more of a solid evolution than a total leap forward. In some ways, its design philosophy sits closer to older engines from the 1990s than to the newest fuel-saving designs flying today. One important number here is called the bypass ratio, which is basically how much air flows around the engine core compared to how much flows straight through it. A higher number usually means better fuel efficiency, which means airlines spend less money and burn less fuel per flight. The new Chinese engine is reported to be around 9-to-1, with some sources hinting at future versions reaching 10 or even 12-to-1 down the line. The LEAP engine it is replacing is already sitting at the high end of that range today, backed by decades of fine-tuning and real-world flying experience across thousands of aircraft. None of this means the new engine will fail. It just means the real gap is not really about whether it works at all. It is about whether it can eventually work as well as an engine that has had a 15-year head start in the real world, flying millions of hours across thousands of planes in almost every kind of weather and condition imaginable. Quick question for you before we move further. Do you think 2027 to 2028 is a realistic certification target? Or is China being a little too optimistic here? Drop a yes or no in the comments. I am genuinely curious what you think. And this timeline debate is exactly why the next part of this story matters so much. Why China is doing this anyway. Here is the bigger strategic picture, the part that ties everything together. If this engine succeeds, China removes the one single part of its aviation program that other countries can use as leverage against it. And out of every part of an airplane, the engine has always been historically the hardest thing in the world to build domestically. Harder than the body of the plane, harder than the electronics inside, harder honestly than almost anything else in modern manufacturing. China's newest national 5-year plan, covering 2026 through 2030, actually spells this out directly in black and white. It formally prioritizes both growing C919 production and speeding up this domestic engine program. This is no longer just one company's side project buried in a research lab somewhere. It is now written into national policy at the highest level of government, with real funding and real deadlines attached to it. So what does this actually mean in terms of real business? Right now, orders for the C919 total more than 1,000 according to official numbers, which sounds impressive on the surface. But if you look closely, most of those orders come from Chinese airlines and Chinese leasing companies, not from the rest of the world. International airlines outside China have been far more cautious about jumping in. Without full certification abroad, and without a long track record for either the plane or a homemade engine, most foreign airlines are simply not ready to commit their money and their reputation just yet. Buying a new aircraft is a decision worth billions of dollars, and airlines tend to wait for years of proven safety data before signing contracts. A working domestic engine could change that math in two big ways, and this is really the heart of why this whole bet matters so much. First, it removes the risk of relying on a supply chain that another government can shut off with a single decision, the exact kind of decision that stalled deliveries back in 2025. Airlines and leasing companies hate uncertainty, and a fully domestic engine removes one giant source of it. Second, it opens doors in countries that do not require the same strict Western approval process, especially in regions where China already has strong trade relationships that can move faster than a formal certification process usually would. These markets might not have the same brand recognition as Europe or North America, but they represent a huge number of potential passengers and growing airlines looking for affordable, modern aircraft. That is really the bigger prize sitting at the end of all this. This is not really about replacing Boeing and Airbus in places like London or New York anytime soon, and it probably will not be for a very long time. It is about building a reliable, independent airplane that can compete for buyers across the rest of the world's narrow-body market. a market where Boeing and Airbus currently have almost no serious rival at all. And this story does not stop with just one engine either. The manufacturing skills being tested here, 3D printed parts, advanced titanium blades, high heat coatings, do not stay locked inside one single program. These same techniques feed directly into China's next big project, a larger wide-body plane called the C919, along with its own scaled-up engine built using many of the same lessons learned from this smaller program. Some of this same turbine technology has also quietly shown up in newer military engine designs as well, proving that whatever is learned here spreads far beyond just this one aircraft. Every successful test, every improved blade design, and every lesson learned from delays becomes useful knowledge for the next generation of Chinese aircraft, both civilian and otherwise. So this is bigger than one plane and one engine sitting under a wing somewhere. It is really the foundation for an entire independent aviation industry being built one careful part at a time, with this engine acting as the very first real test of whether that whole vision can actually work at the scale China is hoping for. If you found this breakdown interesting, make sure you are subscribed so you do not miss the next video, and turn on notifications so you catch it the moment it goes live. I would love to know what you think in the comments below. Do you think China pulls this off on schedule? Or does this engine end up taking even longer than 2030? Let me know down below, and I will see you in the next one.